and we are very focused on data-driven applications and use cases. And the kind of thing that differentiates us from traditional venture capital funds is that we have a set of operating people, a CTO, product people, and so forth, who work very closely with the companies. The general areas of focus are around IoT, online, and enterprise, and those themes, AI-driven automation, moving from workflow-based applications to data-driven applications, security and privacy. It's no surprise that we're doing an event in 2 weeks on digital factories. That's an area of focus. Blockchain, much like we would think of Spark and Hadoop as enabling platforms. We think of blockchain as an enabling platform, which is driving disruption in financial services and IoT, smart contracts, and so forth, augmented reality, virtual reality, and computer vision. Our companies are looking for people, so Neva is a company that provides an AI-driven autonomous agent for IT service and support, looking for people. And Sensify is an IoT security company leveraging blockchain. So if any of you are interested, just catch me afterwards, and I'd love to tell you about it. If you're tweeting today, use the hashtag Hive Data so others can also follow. I'm incredibly privileged to introduce Raghu Ramakrishnan, who is CTO of data at Microsoft. Many of you probably know him also from his previous tenure at Yahoo, where he, towards the later part, was the chief scientist of Yahoo. And if you are a lot younger than I am, you probably studied at Wisconsin, where he was a professor, or followed his books. And as Mohan pointed out, he studied at IIT Madras and Austin, that C. Mohan here also shares the same schools in common. So please join me in welcoming Raghu.
Thanks, Ravi, especially for establishing that we can now blame Mohan for anything I get wrong. Okay, so it's great to see you all here. In fact, I see some former students here, which is especially nice. So without further ado, let me get going. Today I'm going to talk mostly about the big data stack.
Okay, that sign is a problem. Thank you.
There you go. You see, Mohan is already adding value. So, today I'll talk mostly about big data, which is part of the Cortana intelligence suite that contains, we call this our happy meal. It includes Hadoop, the HD Insight offering, the data lake, machine learning, Power BI, the data movement offerings, streaming, a whole collection of things. But beyond that, we have several other assets, all of which go to complete the picture. And I'll speak a little bit at least about SQL. SQL Server 2016 is the latest edition in a long line of SQL Server releases. And the interesting thing here, the guts of SQL 2016 were baked for many, many months in the cloud as part of Azure SQL DB and Azure SQL DW. The line between our on-prem offerings and our cloud offerings is blurring and blurring rapidly, right? You'll also see that SQL Server has now become a vehicle for R. So across the traditional relational space and the newfangled machine learning, advanced analytics space, on-prem or cloud, SQL Server serves as sort of the anchor tenant for our data services. Lastly, we recently acquired a company called Revolution R. Okay? This is because we really believe in R. We want to stand behind it, enterprise grade, and so Revo is the acquisition that helps make that possible. We do a Red Hat kind of model in supporting R integrated deeply into our Hadoop offerings, into Teradata, both in Windows and in Linux. Speaking of which, Sebastian here said that he saw this penguin which says Microsoft loves Linux, and he told his friends hell has frozen over. And I told him, have you heard about SQL Server on Linux? Not only has hell frozen over, you can now build igloos on it. So Microsoft is indeed embracing open. Let's start with SQL Server briefly. I'll just cut through all the animation here for a moment. Bottom line, lots of cool stuff. Gartner loves us. I learned this very important piece of business wisdom from Mike Stonebreaker. He said, any graph, top right is where you want to be. Okay? So, not having an MBA, I found this incredibly informative. It's good to see Microsoft up here. All right. Security, we have long been seen as a leader. Data warehousing, some of the performance improvements have really been a distinguishing mark of this particular release. And this is something I'll talk about a bit more. One of the things we're doing is making the reach of SQL Server for analytics broader and broader. Right? It's no longer just for relational queries. In-memory across all workloads, in-memory OLTP with Hackathon, in-memory analytics services. This is an area where we have invested a great deal in SQL Server. As you will see, it percolates both on cloud and on-prem. First off, let's talk about the in-memory analytics. You can now, thanks to the Revo integration into SQL Server, run full R inside SQL Server without ever moving your data in proc. Okay? You can do the same inside Hadoop if you want a scaled out version. Right? But it's notable that it's right inside SQL Server. Okay. And R itself, of course, remains open source. We are totally committed to that. The Revo R service, basically, like I said, I'll keep this simple. It is the enterprise grade version of R. Cloud, this is something I also want to touch on a little bit. SQL DB, the core bits are shared in common with SQL Server. Many of the new features in SQL Server were first seen available publicly as part of our cloud offering. Now, our cloud offering also has several other things. Small databases can be sprayed across many database instances. We manage all that seamlessly. Literally, there are millions of databases, customer databases that we manage, and we don't certainly have millions of instances. But those kinds of multi-tenancy, that's layered on top of a core that's shared in common with the SQL Server that ships on-prem. And therefore, some of the much faster dev and deployment cycles that you see in the cloud are in fact being used to accelerate and to harden SQL Server development. Okay? Which also means, as a customer, people see the same thing in both the cloud and the on-prem versions of the software. Stretch. On cloud, obviously we are emphasizing our investment in Azure, but equally we have a franchise on-prem. And one thing we hear often is people want to be able to operate in hybrid mode. So the stretch feature in 2016 allows you to essentially push parts of a table. You can select that, and when you do, that is pushed. Older, colder versions of the data are pushed to the cloud. When you actually issue a query that touches the older data, that is surfaced and returned to you. This is transparent to you. Effectively, not only is your data being pushed to the cloud, some older part of it, As a consequence, your computation also bursts into the cloud when it touches the part of the data that's in the cloud. Okay? Keep on moving. SQL DW. This is our Redshift equivalent, if you will. It's an MPP database. Again, the core bits are from SQL Server, right? And one thing that's different from Redshift, we leverage Azure storage in a way that allows you to scale your storage independently of your computer. So details essentially boil down to your data at rest is charged based on the storage costs. To compute, you hydrate your instance and then you do your compute. Okay. The main point I wanted to make here, the common element, again, SQL Server. So all said and done, there are a couple of these graphs, something went wrong here. Net, all you need to know, top right. Okay. With that as context, now let me get to the meat of this particular presentation. The Cortana Intelligence Suite is the collection of offerings that includes big data, but also advanced analytics in general, and it's a cloud-first focus. Okay? There's a range of things. Azure Data Factory is an orchestration engine, sort of like Uzi for those of you from the Hadoop community. Azure Data Catalog, Edge Catalog on steroids, if you will. Azure Event Hub, like Kafka, like Kinesis. SQL Data Warehouse, we just talked about, like Redshift. Azure Data Lake Store, I will talk about in much greater length. Azure Machine Learning and Stream Analytics. Speaking of Stream Analytics, we support Storm, and very recently Twitter open sourced Heron. We worked with them to get Heron on Yarn, you owe me dinner. Let's keep going here. We also support Power BI and deeply integrated with all of these other offerings for dashboarding. Cortana. There's also a collection of ML APIs, right? The Project Oxford APIs for face recognition, sentiment analysis, and so on and so forth, which are accessible through APIs for you to both train and score. Okay. And as I'll show you briefly, we also have pre-cooked templates that pull together many of these to let you do certain scenarios end to end. And the intent is not that these are in themselves completely polished vertical apps, right? It's like you want to write a paper in, I'm going to show my age, LaTeX, okay? Yeah, and you don't know LaTeX, no problem. As long as you have a template, you just go in there, strip out the other guy's text, stick in yours, right? And you change a number here, the font grows too big, reduce it, just right. You get the idea. This is the same principle. You have templates that you can directly tweak and use as a starting point for what you want to build. You have something to get you started. I'll show you at least an instance of that briefly. Of these, what I'm going to talk about today is this core, okay? All right. The point behind all of this, the variety of data, the types of data, the sources, the nature of the processing, the modality, interactive, streaming, batch, all of this has changed, right? And what people essentially want to do is store all data, do any kind of analysis that's appropriate on that data, any speed, any scale. They don't want to have 10,000 machines invested up front. They want to be able to burst up to that as needed, when needed, and then shrink back down, right? And lastly, hybrid. They do want to be able to do more and more things in the cloud, but most also want to retain a presence on-prem, and often this seamless hybrid behavior is a key driver for them. All right, I promised you a template. Let me give you a very, very brief vignette. There's actual code and templates downloadable that correspond to all this. So imagine that you have data sources that include sensors that you're actually gathering and shoving into Event Hub, right? Event Hub. Can you see this pointer?
Yeah.
Okay, great. So Event Hub, as I said, is our Kafka equivalent. You can get And we support Kafka too, by the way, right? Data from those sensors is flowing in here. You can also have feeds from a number of social feeds, Pinterest, LinkedIn, Facebook, and so on, Twitter. You can have your own on-prem data sources, including weblogs and traditional relational databases. These batch sources can go directly into a store in the cloud, say Azure Data Lake, or for that matter, into Azure Blob Storage. You can use the data factory to orchestrate how you sync the data, how you move the data, all of the ETL. From the event hub in the usual architecture, you can do streaming analysis as data comes in here, pull it. You can use HT Insight on data here, or for that matter, in conjunction with streaming data to do lambda analysis. You can do machine learning. You can publish the results into the warehouse. You can consume it using Power BI. This whole thing, many different paths through it correspond to common templates, including this particular one came from a retail recommendation for a real customer. Okay? What is the output of all of this? Oh, I didn't even need to do that. This is an actual screenshot of a dashboard. I'm not going to go into it in detail, but I want to call out a few things. Some of this is your vanilla roll-up, drill-down kind of BI dashboard. Behind these are some SQL queries. In this example, this is a dialect of SQL called U-SQL, which is the dialect that we support in Azure Data Lake. It's very similar to T-SQL. The main difference is you can write user code in C#, and we support that type system very seamlessly. Okay? I'll say more about that in a bit. There's lots of feeds involved here. Some ticker tape feeds, some other feeds, news events, churn history, transactional history, and so on. Some of this is being analyzed in this particular scenario using Spark, some using Azure Stream Analytics. Some of this is being analyzed using ML models for risk, right? And let's take this particular alert, which says suspicious trading. If you click on that link, you will be taken to something like this. That shows more details of why certain trades were those trades were considered suspicious. Another thing you could do is to say, hey, wait a minute, some of these query results are odd, or I want to introspect on the actual query execution. Now, if you're a business consumer of this dashboard, you would click on this link. If you were a developer trying to debug why some of the reports turned out the way they did, you could drill down and see what the actual query execution did. I'll say more about this later, but this is the geeky view, the geeky drill down for the developer of U-SQL. So this is a snapshot of the full execution, right? You can look at it. In this case, it's showing execution time in the various vertices, and it's color-coded, right? Red, a lot of time was spent here. Blue, these didn't take all that long. By using different drop-downs, you could analyze I/O, CPU time, so on and so forth. And every single query is recorded, and you can play it back, okay? And from many different perspectives. All right. What's behind all of this? Now let's segue into more of a technical view of all this. Here is the full stack. I'm not going to get into all of this in detail, but I do want to call out some of the implications and explain why we are doing this. First, if you take the data, you can store it in VAS, Windows Azure storage, remote storage, blobs, cool storage, whatever. We also will support your ability to cache this in compute tier clusters. On top of all this, Azure Data Lake gives you an HDFS API, an HDFS++ API. There are some extra things there, which I will talk about. And this at scale, more on that in a moment. When computing, right, we double down on yarn. These things you see here, Rayon, Federation, Mercury, Yak, all of these are enhancements that came out of Microsoft, but they're all now completely pushed out into Apache Yarn at various stages. But But our philosophy with Yarn is to work completely in open source, right from the outset, filing JIRAs, engaging in discussions, and the code actually goes out there. In fact, we also participated in porting Heron to run on Yarn as part of this open source process. We also open sourced Reef, a library we use to develop various AMs on top of Yarn. Everything we run as compute, including our own proprietary U-SQL, as well as open source things like Spark, MapReduce, Tez, we run as AMs on top of a shared resource manager, namely Yarn, right? So the net result of this, we want to be able to tell customers, you can store your data in an HDFS service, and once you do, you can consume it through your favorite open source tool or one of our proprietary tools, or both, even concurrently, right? You're not locked into one or the other, right? That's our basic value proposition. There are also some things like SQL DW, cluster service, the IaaS VMs in Azure, all of which also give you access to the underlying infra pieces. Okay, yes,
What is
please.
Cosmos?
Thank you, I'll get to it in a moment. Cosmos in a nutshell is our internal big data store. I'll have a lot more to say. Okay, this is the big data service that Microsoft runs on. This is Cosmos. So Cosmos was a project started roughly at the same time as Hadoop was started, but Microsoft chose not to open source it. So Cosmos is technically the file system, the HDFS equivalent. Scope is the Hive MapReduce hybrid that runs on top of Cosmos. This is our first party stack. Okay? We are currently on a journey where we are aligning our first party and third party stacks. I'll say more about that. But let's take a look at this service. So at Microsoft, all of big data runs up into one group. I basically am responsible for supporting this, as well as all the external big data work we do, which is why we're also trying to align all of this together. Okay? Ultimately, we're not quite there yet, but there's a path we're marching on. Ultimately, if you're an Azure customer, you're running on the same stack, likely in the same data centers that Bing is, that Xbox is, that Skype is. Okay? Xbox, Bing, Windows, Exchange, phone, everything, Office, Skype, Yammer, doesn't matter. Virtually every part of Microsoft has a fundamental production dependency on this, right? This is our data lake. If something is down for 10 minutes, I get paged by people I don't want to be paged by, okay? If it's an hour, I turn off my pager. All right. The number of internal developers is in the thousands. The number of daily jobs we run, hundreds of thousands. The amount of daily I/O, just daily I/O, several hundreds of petabytes. The total amount of data we manage, several exabytes. And these numbers are growing at an exponential clip. Our cluster sizes, the largest Hadoop cluster I'm aware of is 4,000 or 5,000 nodes. Our smallest cluster is 10 times that, right? The number of machines in total across clusters is in the hundreds of thousands of nodes, right? This is our big data footprint. And everything we're doing is grounded in that reality and the learnings from that, okay? So let's take a step back. At the highest level, here's how I think about both how we used Hadoop while I was at Yahoo and how we use Cosmos at Microsoft. If you think of data lakes, they're really the evolution of a traditional data warehouse. A traditional data warehouse, now really, you think top down, okay, about the world. You think about a business scenario, you understand it, and then you want to track how it's evolving relative to your expectations, okay? In contrast, in a data lake, you're trying for something different. You're capturing data, not quite knowing what you're looking for, but anticipating that there might be insights to be had. And you're trying to explore, you're trying to discover, okay? If you take these, in one case, it's really useful for precisely describing the most well understood parts of your operation and making sure you understand and track changes as they occur, right? If you want, for example, to know the distribution of revenue by division, by product line, you have a pretty good feel. And if there's any change you want to know, you want to be able to drill down, you want to validate your hypotheses, you want to apply corrective action. That falls squarely here, right? Now, why did it happen? The diagnostic analysis, more here. When you get a machine learning and predictive analytics, hey, this customer is likely to be a good bet. That is likely to be a fraudulent transaction. That falls somewhere here. Prescriptive analytics, how do I increase my acceptance rate for an offer? How do I reduce churn, right? Those kinds of things are up here. And if you take this continuum, that's what it is, a continuum. Traditionally, we focused on this. The underlying data was highly curated, mostly relational. Nowadays, we are seeing a lot more buzz around this, but make no mistake, this doesn't go anywhere. This continues to be super important, okay? And so, if you look at traditional data warehousing, it dealt with the left-hand side of that picture very well, and it led to the artifacts we think of as a data warehouse, the BI and analytic dashboards, presentation tools, ETL, so on and so forth. If you take the data lake, it really deals with the right-hand side, more naturally. You get data from IoT sensors, and the volumes are staggering. If you look at the dashboard of a tractor, it's more sophisticated than the cockpit of a fighter jet. Okay? You go down a row, and the dosage of manure that you deliver depends on the soil acidity of that plant, its neighbors, the rainfall in the last week, the trends of acidity, the signs of the zodiac, I don't know, all of that. Think of the amount of data involved. I heard, and I don't know if this is true, that there was a $1 billion unicorn that basically did data analytics for data from practice. I don't know if I even believe that, right? But that's sort of where we're going. When you're dealing with this kind of data arriving in real time, often requiring a read and react response, you don't have time to curate it. You don't have time to do schema integration. You just grab that data and stick it someplace where you can come back to later. Maybe along the way you do some immediate reaction, but that's about it. On that, you now need to be able to do non-trivial analysis over data that is unstructured, that is dirty, that is not fully reconciled, because you are effectively cleaning the data on demand for a particular purpose. Okay? So batch queries, interactive, real-time, machine learning, these are not only needed, but advances here are the enablers for this paradigm. Now, one of the things that's trending, and depending on who you talk to, the belief is stronger or weaker, that if you take traditional tabular data, that can also be a type of data here, and if you take traditional relational queries, they can also be a type of query that is satisfied equally well by the software and services that emerge here. In other words, the left-hand side folds into the right-hand side. Whether that happens or not, I am agnostic, but net-net, when I think about the data lake, data warehouses, this is the continuum I see. So I really think of big data as being in the business of the next generation data warehouse. Right? So if you think of it that way, I already talked about this, I'll keep moving. There are several lessons we take away from our experience dealing with Cosmos on a daily basis. Some you're very familiar with, I'm sure. Handling failures from the ground up. If some part of a query fails and it's running on 10,000 nodes, and yeah, by the way, we have production queries that run on 10,000 nodes. I can't afford to restart the query. Too bad, right? You need to think about failure, partial failure handling from the ground up. Sharing data becomes incredibly powerful. The reason our clusters are so darn big, You have data, someone looks at it, produces something useful, says, let me put it out there. Others, as long as they're able to discover this, they take this plus the original data, they find it a bit more useful, they produce even more. You can see the virtuous cycle. We see this, right? You need to leverage parallelism. You need to be data aware in everything you do. You do not scale to hundreds of petabytes of I/O without making sure that the vast majority is machine local, and the vast majority of the rest is rack local, and so on. Okay? No matter what you hear about networking speeds and the like, this is a truth. Okay? Finally, all of this, the moment you start to deal with enterprise-grade scenarios, the moment you offer these as platforms for other companies to use, the moment you have first-party customers such as Office who have to deal with personally identifiable data, unless everything is secure, compliant, provides governance, you're toast. And the implications there are far-reaching. I'll come back to that as we go. I'm happy to say that what we're doing received some tender love in the Forrester Wave. As an academic, I think of this as the industrial version of the US News and World Report college rankings. Okay? Again, top right, baby. Excellent. Let's keep going. Where should the data be? I can't tell you how much of a thrill I get putting up those 2x2s and saying top right. Okay. Let's switch to a more technical look at this. I think there are two fundamental questions, right? Frankly, even I am bewildered by the sheer plethora of tools that are springing up. This is an incredibly fertile field. But there are a couple of questions that I believe are truly fundamental, and they keep coming up no matter what you do. So let's talk about them for a moment. The first, where should your data be? There are two conflicting trends that all of us are grappling with. First, because of the increasing need and popularity of interactive and real-time analytics, you want your data to be readily accessible. That means in memory, non-volatile RAM, SSDs. You want to move data using RDMA and the like. This is relatively expensive. On the other hand, the massive volumes you're seeing means you also want to store data at rest in the most inexpensive form. Okay? In fact, Facebook is investing in data centers specialized to cold storage. On the other hand, we see any number of systems that are optimized for purely in-memory execution. GridGain, Spark, Presto, on and on. So, what is a poor customer to do? If you store your data in Azure's blob storage and pull it in for processing in something else, you're crossing system boundaries. Maybe one is compliant, maybe the other is not quite, maybe one has HIPAA certification, maybe the other only has SOC. Who the heck is going to think through all of this? You remember that big template I showed you when you're moving your data across the system and doing umpteen different things? Who's going to keep track of all of this all the way through? And when you create a piece of data, you want to make sure it's secure, it's authenticated. You want to make sure you control who can access it for what purpose. Well, are you going to do this for every intermediate envelope that the data passes through? Things like compliance and security are a pain in the gut, are a pain in a sensitive part of the anatomy. Okay? So you don't want to do it any more times than you need to. The conclusion you get to is your underlying storage system needs to do a better job of managing the memory hierarchy for you. At the very least, give you control over when what data needs to be where. Okay? That's what I mean when I say tiered storage. Simply storing data in one place and sucking it in to do something someplace else is a very poor man's approximation. Ultimately, you want this to be policy driven. You want it to be within secure, compliant boundaries, right? That's where I think we need to go. A second fundamental point to think about. We're now talking about analytic systems that are dealing with a much wider variety of data than relational databases and a much wider variety of computation than relational queries. One of the things that has happened happily is some standardization on the sockets, HDFS, Yarn, any resource manager. This allows you to plug in different engines developed even independently by many different companies. Hive from Facebook, Pig from Yahoo, Storm from Twitter can all happily run in multi-tenanted fashion on the same machine. Okay? This is important because when the data gets to be the volumes we are talking about, creating copies of the data across multiple clusters for data marts is not exactly a great option. Okay? When you add to it the tiering part of the story, it most decidedly is not a great option. So the key question is, when you have many different jobs or many different job types submitted on behalf of many potentially differently privileged users, how do you control the policy on allocation of resources? Especially when the resource requests for different jobs come with all kinds of unique constraints. A Hive job or a Spark job is very sensitive to the computation being co-located with cached copies of data. An MPI job is massively sensitive to communication locality, right? Collections of things need to be very close to top of rack, if not on the same machine. How do you allocate with these kinds of constraints taken into account? How do you also do things like, I can afford to wait, I'll use spot pricing. No, I need this to run exactly at 8 o'clock and I'm willing to pay a premium, right? These are the kinds of assertions a user wants to make. The challenge and the opportunity for us is to let them say that, and then underneath to have the ability to implement these policies. Of course, the one lever you have is the more finicky people also need to pay more. Right? Model of that, you want high utilization, high yield. Right? How do we do this? This is the challenge of resource management with multi-tenancy and SLAs. Don't forget SLAs. Right? Without SLAs, there was a recommendations company, I'm not sure I'm allowed to give the name. They were in the cloud. They needed to have their recommendations up and going at 6 o'clock every morning. And because the SLAs were broken a few times a month, they just redid the whole darn thing on-prem. That's how critical SLAs are in a production setting. Right? How do we do this? Okay. With those two questions in the back of your mind, let me segue into some of the things we have built. First, Azure Data Lake Store. I told you about Cosmos. Cosmos is our internal data lake, our internal HDFS equivalent. Azure Data Lake Store is intended to be Cosmos vNext. Okay? And when all is said and done, our intent is that Cosmos clusters will be migrated to be ADLS clusters. Right? The version that is already there is a fully managed cloud store, HDFS. So all HDFS APIs are supported. You had a question?
No.
Yes, sir? No, okay. And essentially, you can store files of any size. You can get the bandwidth you need to get at the large files fast enough. Low latency injection. This is a non-HDFS feature. In addition to 4 meg batch writes, when you do small event writes, right? These are automatically written to 3 SSDs and ACT, and then aggregated and batched to disk. Okay? And furthermore, you don't have to wait till the file is closed to read it. You can read as the file is being written. Essentially, as extents are sealed, you get to read them, which means if data is being pushed in fast, you see data almost instantaneously. Right? Authentication is through Active Directory. In enterprises, Active Directory has penetration in the high 90%, somewhere there, depending on you look. AAD is Azure Active Directory, the version of it on Azure. So if you're an enterprise customer who runs AD on-prem, immediately all the roles and IDs you have defined on-prem, you can basically say authenticate those same things on the cloud. And for these roles, these users, these are the privileges on these ADL files, and you're done. That's your authentication. Right? File and folder level access, full POSIX file structure, and encryption at rest. We'll also add encryption in motion shortly. Your keys can be stored on a server-side HSN, or you can manage it on the client side. We'll give you lots of options. Okay? Security, encryption at rest. Like I said, transparently encrypts data that flows from networks, public networks. Our encryption is server-side, not client-side. Lots of flexibility in terms of how you manage your keys. Access control, what you would expect. Here's an example. I don't think for this audience I have to go over this in detail. It's what you would expect from POSIX. For getting data in, we give you lots and lots of options to get your data in fast. You can get data in from many common sources: SQL DB, DW, Azure Tables, on-prem data, through Azure Data Factory or through Apache Scoop. We can get, you use Flume, we give you a built-in copy service, you can use the scripting APIs, plenty of ways. Or you can put data into Event Hub or Kafka and process it and stick it into ADL as well. Okay, egress, exactly the same story, I'm not going to get into it. Now let's look into what's behind all of this. When you make a request to read, write, whatever, it comes to what we call the secure store service endpoint. This, the first thing it does, and all of this runs in the compute tier of machines. So Azure VMs or the equivalent thereof. This actually runs on bare metal, but that's a different story. You come in here, you translate the file name. So remember, we have a logical namespace. So you look it up, then you make sure that the request is coming from someone who has the appropriate ACLs. Then you go back, you query the metadata, think of this as the name node equivalent, to find out exactly where the relevant extents of the requested data are, and then you can go ahead and fetch the data. The data itself, today in V1, which is what is in public preview today, it's in Azure Blob Storage. In fact, across many accounts, we stripe across these accounts, which is how we give you unlimited bandwidth, if that's what you want, if you're willing to pay for it. More on this in a moment. This is already, the performance is comparable, a little, actually, depending on the scale, considerably better than what you get running on top of Azure Blob Storage or say EMR running on top of S3. But this point about tiered storage, how does that manifest? Coming soon, you will see this enhancement. You will also see in the compute tier the ability to cache your data. And you will have the ability to say, this file needs to be here or here. Or here's a budget, and within that budget, store my files here, the rest can go here. The first month of a file, keep it here. Later, move it here, right? You get the idea. 8 o'clock every morning, this file needs to be here. After 9, it can go here, right? Now, what happens if the file you want is only partly here? No worries, the rest it's treated as a page fault. You go back and forth. So maybe this is a slow, slightly degraded performance, but as long as this is the exception, not the rule, you're not going to really notice. Okay? This is tiered storage, this is not yet there, but fine, right? And furthermore, in here, while I've shown it simply as local storage, as you can imagine, there's a hierarchy here as well. Local disk, SSD, memory, and so on. Okay. Next, let's look at the analytics. If I think about the analytic part of the offering, first we have HT Insight. This is a fully managed service. You basically come in and say, I want a cluster of size n. And later you can dynamically say, increase the number of nodes or decrease the number of nodes. But you're responsible for sizing the cluster. And the meter is running based on how big your cluster is. What you do is your problem. What you're built for is the resources you're consuming on standby. Okay? We will let you create a Hadoop cluster with pretty much anything out there in Apache Hadoop, HBase, Storm, whatever, right? Spark. We'll even let you customize your cluster with something that you may want to bring in that we don't support prepackaged, let's say Giraffe or something that you wrote. Okay? We support, therefore, batch things like MapReduce, Pig, Hive, Spark. We also support stream processing, interactive processing, HBase for table serving, various machine learning packages, and we do all this together with Windows Azure Active Directory for authentication, and yeah, ignore that. Net integrated with Power BI, all the things you would expect. In a nutshell, it's basically Hadoop, together integrated with various pieces of Azure, including some proprietary Azure services. Let me give you a simple demonstration of an interesting application. eBirds is a long-running project at Cornell where amateur observers say, today I saw a spotted owl in my backyard. And these observations, crowdsourced, have been stored for years in their databases. And today they claim it's the largest such database. 14 million field hours contributed by over 100,000 observers, millions of bird observations. And they've built lots of applications with it. Recently, the Department of the Interior released a State of the Birds report, Canada, the US, Mexico jointly. Let me tell you what they do with it. So here's an animation of what's happening over time. This displays the number of birds seen in a given location. Obviously, the more the intensity, the more the birds are there. That underlying data is within a square kilometer per sighting and within an hour or so per sighting. You can see how the migratory patterns are seen, right? And what do they use it for? Oh, during a certain part of the year, this becomes a critical path for migratory birds of a particular species. And hey, this winter is cold. It would be good if the farmers in this area delayed their harvest by a month. How do we incentivize that? We'll have a program where we'll set aside some money if a farmer volunteers to do that. Where should you set up such programs, and how do you invest a limited pool of money in such incentives? These kinds of databases are what they're using, right? Pretty cool. If you're interested, go take a look. Now, if you take HD Insight, it can run with its data in either blobs in Azure with a HDFS interface to that, or it can run with the data in Azure Data Lake storage in a truly HDFS service. Both are fine. But you could also do something else. Internally, in the Cosmos setting I described, you don't say, give me a cluster of 100 nodes. You say, here's my data, and anyone can then come and say, here's a query over that data, right? This is similar to say BigQuery rather than HD Insight or EMR. Azure Data Lake Analytics has this form factor. It's built on Yarn, scales dynamically, you pay by the query. Again, with Azure Active Directory for access control. The language is U-SQL. U-SQL is as close to T-SQL as we can make it, with some necessary differences in the type system, because we support C# and C# types in a very closely integrated way, as you will see. Initially, we support this only for U-SQL queries, but soon we'll support Hive and other query types as well in this form factor. Okay? All running on top of the core Yarn and Azure Data Lake store. Okay. So you basically log in, create an account, write a job, submit it, get the results. And these are very complementary. The HD Insight clusters are good for power users and for users who want to run custom stuff that maybe we are not comfortable running in a shared environment. The ADLA form factor is good for customers who want ease of use and who want to burst up, especially for interactive use, without having to go through the intermediate step of setting up a cluster and determining how long to keep it up. Okay? And there's no, this is better than that. Both are useful, we'll support both. It's a matter of what the customer decides is best for their use case. The language is based on scope, which is the workhorse I described on Cosmos. The main difference, it's been re-engineered to run as a yarn AM, every query. And the query language, as I said, has been refined to be fully aligned with SQL. So quickly, the philosophy behind U-SQL, it's SQL. At the end of the day, it's a declarative language. The query optimizer does its best to produce a good plan for the entire query, including the user code, to the extent it can understand that or get statistics describing. It's optimizable, scalable, operates on both structured and unstructured data. This is really not so much for interactive use, although it's reasonable. Its real strength is for data prep. You can take virtually any kind of data, documents, web logs, and clean them, prep them, and get them ready for training, for other kinds of stuff. It's part of a full cycle pipeline. You don't even need to have a schema known a priori. You can impose a schema on the fly through extractors. We provide a full library. You have, just like in a relational database, you have a catalog with things that describe every file, every table, and it's fully extensive. The extensibility is currently based on C#. Over time, we'll support other language bindings such as Java. Today, you can use C# to define everything from user-defined functions and types and aggregators and operators. The whole parallelization and scale out of all this, dealing with failures, scaling, all handled by us. Okay? So net, here's an example of an extractor. One more thing I should point out, federated queries. The core data source for U-SQL is Azure Data Lake store. However, you can also get at data by defining external tables. These are tables in Azure Storage Blobs or SQL VMs or even on-prem SQL DB or even on-prem. Okay? And then you have a federated query. Not only do you have that, you can combine external and local data, do joins over them. It's pretty general. Now, if you take a query, sort of like relational algebra, there is a structure to it, and you can define this concept of vertexes, right? In every vertex, there's some work. You can map a program into a collection of vertexes. Each vertex, right, is part of some stage, and this yields a certain structure. These things are happening together, and that's a precursor to this. You get the idea. This structure, every job has this structure. We use this as the basis for helping you keep track of your job visualization. The picture I showed you earlier, here, as you can see, this is simply progress of your execution. The job just started. These two nodes are complete. There are statistics on how long it took. These two nodes are in progress. These haven't yet been initiated. Here are ongoing stats. Okay? It's continuing. Now it's over. This, the same job, you're replaying it, and you can replay this while the job is running, or you can go, have a cup of coffee, come back and replay this at your leisure. This, the pull down here says execution time, and the color coding here, blue, means light. So this node didn't take very long at all. This took a reasonable amount of time, these two nodes. Get the idea. You can flip that to say I/O, and you can see which nodes were I/O intensive, okay? And so on. There's one degree of freedom you as a customer have. You can control the degree of parallelism, right? If your data is large, if you give it 3 nodes of parallelism, it'll take a little bit longer than if you gave it 3,000, okay? And we ask you to choose because this has an implication on how much it might cost you. We also give you what-if tools, right? There's a point at which offering more parallelism doesn't help because there isn't enough parallelism in the program to leverage what you're paying for. So again, we give you what-if tools that say, let me control the degree of parallelism and tell me what would have happened. It ain't perfect, but it gives you a good fee for what the possible cost would be. So there are all these kinds of things that we provide, and let me, without further ado, just let this run for a bit. Here's an actual animation, a video. Not an animation, a real video. All the things I said. This is in real time as the job is executing. Right? Okay. hopefully what's going on here should make sense. You can click on any vertex and see detailed statistics, right? For that node. You can click and see the execution traces, the logs from that node. Right? You can look at the amount of data read, written, execution time, averages of various metrics. Okay, let's keep going. You get the idea. Now, when these jobs run, I said they are running side by side with other jobs from other users of multiple job types. Not only U-SQL jobs, ultimately Hive jobs, ultimately Spark jobs, and so on and so forth. And there is some common gatekeeper for the underlying shared resources. That is Yarn, right? This is the second fundamental question I asked. So let's talk about resource management briefly. Resource management in a nutshell is one of the innovations here. Database people have been thinking about risk architectures for a long time. I actually think the big data world has come up with a fairly reasonable cut at it. This notion of, hey, have an underlying store that can be shared, have a common resource management fabric, and build custom AMs that reflect the uniqueness of graph processing versus stream processing versus different kinds of batch processing. It's a very reasonable trade-off, okay? Maybe it doesn't go all the way to a truly risk architecture, but it goes a big step in that direction, okay? And the job of a resource manager is to allocate compute resources. And the compute asks can be very nuanced. I might come and tell you, I want 100 containers close to these pieces of data that my query runs over, and then another 100 containers after that is allocated and completed, right? So you could have gang scheduling, you could have location affinity, and you might even say, as I said earlier, constraints like, I need 10 containers and another 10 containers. I don't care about where they are, except these 10 need to be very close in terms of communication, and these 10 need to be very close in terms of communication. That's the kind of thing you would say for MPI jobs. Right? In addition, you may have affinity based on a given tenant, right? So the ability to take requests of these diverse kinds, do the allocation in a fair manner, and fair may mean if you pay me more, I'll give you more and quicker, right? Fair here is very nuanced, right? This is the job of the resource manager. Yarn is one of them. This is the one that's commonly used in the Hadoop world, Hortonworks, Cloudera, we all kind of use this. Cortana from Facebook, Mesos from Mesosphere, Omega and others from Borg, Kubernetes, from Google. These are all in the same class. So in a nutshell, to reinforce what I said, you have tiered storage, you have data cached on a bunch of machines. On those same machines, you have compute resources, which are being, the gatekeeper is the resource manager. The relational query engine is implemented as an application master. So when you submit a query, the service, the query engine, the relational query service creates an AM or application master, which on behalf of your query negotiates for resources appropriately with the underlying shared resource manager, and then executes your query. Simultaneously, someone else's machine learning job, its AM may be negotiating to get resources, possibly on the same machines. Right? This is the basic picture. Now, Yarn is exactly the resource manager that's behind a U-SQL query as well. So this is how we mix and match our proprietary stuff with open source. If it's a Hive query, it's exactly Hive. We are not mucking around with it in any way. It's running on top of Yarn and HDFS. But if you run U-SQL, it's our proprietary stuff. We are very upfront with it. And you don't need to schlep your data around in order to run something proprietary at all. This in case. Okay, let's keep going. Yarn is not perfect. Nothing is. But net of it, we are doubling down here. And the way we are addressing this is to contribute. Right? If it's not perfect, we are willing to work with the community to get it to where it needs to be. Some examples, there wasn't a good way to do SLAs. Scalability limitations, as I mentioned, the largest node, largest cluster on which it's been tested regularly is 4,000 or 5,000 nodes. So if you look at the distributions of Yarn that come from the standard sources, this is what it's been tested for. Allocation latency, if you have small jobs, the allocation time can be more than the job execution time. Really helps you for interactive jobs. Specialized frameworks, interactive, long-running services, all kinds of issues. So here, we have in fact made extensive contributions. Amoeba, this is something we did early on, back when many of us were at Yahoo. Work preserving preemption. So you have a job, it's taken a lot of resources, it's still hogging resources, a higher priority job comes along. Your options: kill the job, free up the resources for the higher priority job that just arrived and lose all the work you did. Or what? Wait. With work preserving preemption, you can suspend the job without losing the work and then resume it later. So we contributed this. It's now part of Apache Hadoop 2.6. Rayon provides a framework for making requests of the kinds, the richer kinds I described, and then doing intelligent admission control to guarantee capacity reservation that meets your ask. So once you give me a complex ask, say 10 nodes of this kind, followed by 10 nodes of that kind, if I say yes, I accept this, then yes, you will get those requests. I guarantee it with very high probability, right? So you can build SLOs on top of this. This again is in there. Some newer contributions, Mercury and Yak. One of the nice things we had in our own homegrown optimizer was local queuing. So rather than the global queues you see in Hadoop, local queues at each node. This is a greedy heuristic, which worked very well in some scenarios. So we contributed this into Yarn and integrated it with the global queuing framework. That's Mercury and Yak. And breaking news, as of the last couple of days, it just got into Apache Hadoop trunk, and keeping my fingers crossed, maybe it makes it to 2.8, if not 2.9, okay? Federation. The way we approach this, we want to make sure that people outside continue to do what they care about, which is probably testing Yarn clusters of 5,000 nodes. We are among the few who care about 50,000 node clusters or 100,000 node clusters. So the way we deal with this is through a layer called federation. A federated cluster is comprised of many subclusters. But from the standpoint of a Yarn job, you can present it to a federation, it just runs, possibly over many subclusters. Okay? This is something where we have filed JIRAs, we have done a lot of work, we are now testing this in our own world. This is going to be contributed as well. In fact, now we have asks for federation to span geos, have a single job running in Asia as well as the US. And this is not for reasons of scale, by the way. It's for reasons of compliance. Some data simply cannot be moved. Okay? Yet jobs need to look at the union sometimes. Okay. Framework level pooling. I won't get into details here. This is more nascent, but this is a principled way to deal with small jobs, long-running jobs, interactive allocation times for these specialized scenarios. So you have a concept of a session, you have session level allocation, yeah. Okay. Reef. Since we do so much work building on Yarn, a lot of our work, scale out machine learning, which I haven't really talked about today, scale out streaming, interactivity, batch. Since all this is being layered, we found ourselves doing many things over and over again. So Reef is really a library that simplifies development of AMs on top of Yarn, right? We open sourced this as well. It's now beginning to take off. Lots of people from outside of our organization are actually contributing. You're welcome to use it and to contribute. If you have further questions, here are some places for further reading. I'm happy to take any further questions, discussion. Thank you.
If you have any questions, if you can come to the microphone, that would be
Yep.
nice. Questions?
I'll take the first one since I'm closer to the mic. You talked about data warehouses, and my interpretation was you're saying it's not dead, right? It's still alive, and the competition from the Hadoop vendors to build just-in-time data warehouses will only go so far. What are your thoughts on logical data warehouses using data virtualization kind of technologies?
So let me be clear. if you take, the definitions will morph, right? But if you take the phrase data warehouse, traditionally we have applied it to collections of relational data, curated a priori, and consumed using a combination of relational queries and tools like BI, Power BI, and Tableau.
Like the OLAP and Microsoft Analysis.
Exactly,
Services.
exactly. That class of scenarios will absolutely continue to be important. Arguably, CPU for CPU, byte for byte, probably the most valuable. Okay? By definition, those curated data for very highly understood and high dollar value scenarios. What is becoming abundantly clear is people are now expanding their reliance on data. Data is infusing virtually every single business decision that every single organization takes, including some of the predictive and prescriptive kinds of scenarios. For these, you need a new class of tools. But at the end of the day, there's still data collections. A lot of the principles and practices behind data warehousing. How do you collect the data? How do you ETL it? How do you keep track of keeping it fresh, auditing who created what, when, yada yada, remain the same. It's just that the nature of the data has changed, the nature of the analysis has changed, and therefore the tools have to be a little bit more general. Okay? That's where the whole Hadoop data lake class of things is coming into play. Now I can see two futures where this grows, this continues to grow, and they stay distinct but side by side. Another possibility is this class of data is also supported adequately in here. This class of queries is also supported adequately in the universe of tools that run on a data lake. And over time, these two fuse and simply the pie becomes unified. I don't really know which of these scenarios will play out, but I simply use, when I think about the data lake scenario, to me, it's a natural continuum extending the traditional data warehouse use cases. And if I take the union of these two, my belief, 5 years, 10 years, this is going to be many, many times the scale of the market today, right? I mean, the world is becoming more data-driven at a faster pace than I ever imagined it would.
Hi, a couple quick questions. One, you mentioned encryption, at-rest encryption. Is that that's software encryption? And if so, isn't there a major performance penalty for that?
Yes, what we have today is software-based encryption. Yes, there are risks, and yes, we have thought about it. So the way they have implemented it, they have carefully firewalled the pieces of code that do the actual encryption, and we have already started testing hardware-based ways of replacing this code. There are many options from the major vendors, like enclaves. There are also things you can do with FPGAs and so on and so forth. We're exploring all of them. So at some point we'll also support hardware-based, but we are taking care from the get-go to make sure that introducing hardware to do the encryption doesn't involve a major rewrite on our part.
Sure. The other question is, at one point you said at some point we'll migrate Cosmos clusters to Data Lake clusters. I guess I don't understand the hierarchy. I thought they would be the same infrastructure.
No, all I'm saying is they will be the same. But think about it this way. I have thousands of machines with exabytes of data, and they are running, the software running them is Cosmos. And tomorrow I want to be in the same state, same machine, same data, running the same applications, and oh, by the way, yesterday's apps should have continued to run. And I want this to now be Azure Data Lake storage. The idea of sucking that data with a giant sound into another 100,000 machines or 200,000 machines or 500,000 machines or whatever is not attractive.
Right.
What you want is a strategy where the apps can run concurrently on the same APIs. And the APIs are powered on some machines by one and some machines by the other in a way that gradually allows you to change the mix. One fine day, it's all Cosmos red. Another fine day, some parts of it have started to become ADL green. Eventually, everything is ADL green. That's what I meant.
Okay, thank you.
I have a question that requires a non-political or non-politically correct answer.
I'll ask Mohan.
Okay. Doesn't matter who answers it. I know we are at Microsoft, with everything is all sponsored by Microsoft, but with all due respect and apologizing to Microsoft, do you believe in this whole workflow? You have data acquisition, you have data management, data hosting, the whole gamut of different technologies, including analytics, visualization, all of the above, right? So these are all different types of technologies that come together. Do you believe in best of breed tools for each one of these that play with each other, not from the same vendor? Or do you believe, now here comes the non-politically correct part, or do you believe deep down with your PhD thesis and your teaching experience, do you believe in one vendor providing all the tools, whether they are best of breed or not?
So deep down in my geeky roots, somewhere, some part of me says, booyah, we can build it all. And deep down, by golly, I'm going to try. Let's be honest. If I could come to a universe where we built the whole stack, controlled everything seamlessly, yes, that's the perfect word. Even if it were possible, it'll take a while. And even if I did it, the real question is not whether it is technically the best. The real question is that what the most customers will pay for? Given all the societal and political concerns about lock-in and so on and so forth. The enterprise market is not a winner-take-all. And anyone who doesn't realize this is operating without an understanding of the space. So, the other thing to add here, doesn't matter what I think, doesn't matter what Microsoft thinks. Customers increasingly are looking for flexibility, openness, best-of-breed tools, what they perceive to be the best-of-breed tools. Okay? And so our strategy is pretty straightforward. If something reaches a certain escape velocity of popularity and it uses the standard storage, resource management kind of APIs, and most things that reach escape velocity in this space meet those bars, we will support it. Okay? Hive, you like it? Excellent. The best Hive version in the universe and the cloud? Come to me. You like Spark? Yeah, same thing. Come to me. I don't need to own that. If I can give you the best in-class service, I'm happy with that. And now, if in there I have a few pieces that are uniquely mine and uniquely differentiated, let's say you love ADLS or U-SQL. Okay, maybe that brings you there for some reason, and over time, some part of me says, yeah, you'll soon love it so much because it's so perfect. You'll do everything there. Maybe you will, maybe you won't. That's fine. If that's enough reason for you to come here, this is the beauty of selling services rather than software. I can make money with you running Hive as long as you do it on Azure. I make more money if you run U-SQL, but I'm not greedy. Just come to Azure, you'll settle for it. Okay? In fact, I'll throw in a deal. Run a U-SQL query and you get 2 Hive queries for free. Right? So, okay.
Hey, first of all, great presentation, and I saw the cloud aspect and how you look at things from the point of view of cloud services providers, and then I saw your view on in-premise support, and also about multi-tenancy as a cloud provider, but I didn't see any like mixing of the two. How about if I'm a customer and I want to, do some of the part in-premise, and sometimes I may want to combine this with cloud, depending on how my company grows. So do you guys are building something there?
Yes, so there's a great question. So I touched on it briefly, but let me say a little bit more. For example, we have many customers who use SQL Server on-prem. Then they also want to be able to do some of their computing in the cloud, exactly your scenario. This is the scenario that we are trying to support with things like Stretch, where your on-prem database can push some of the data to the cloud, and then you push a query, it can burst out here. We also support those templates using Azure Data Factory. You can move data from on-prem to, you can orchestrate data movement from on-prem to cloud and back across the different sources you have there. With Azure Data Catalog, we want you to be able to see your total assets no matter where. Frankly, we have a lot more to do in this space, but that's very much our vision, and we started to take steps. We'll do a lot more. Please.
Continue with your question. So you.
Oh, the question?
Continue his question is
please.
on your on-premise. I know that you want to move the data from on-premise to cloud. Do you see any Microsoft in the future to basically completely empty the on-premise and move into the cloud space?
Sorry, move what?
Do you have ever have planned that to completely discontinue the on-premise and move everything onto the cloud? What is the plan for that?
Frankly, no. Right? I mean, we are seeing a few customers, surprisingly, who tell us that is their intent. And we are fine with that, obviously. But realistically, I think most of our customers have certain things going on-prem that that doesn't make sense for them economically, or in terms of the complexity of doing it, right? That they will ever completely get off their on-prem installations.
Okay.
However, increasingly it's clear that a lot, if not a majority, of the computation for virtually every customer, they are trying to get it to cloud. Go ahead.
Right, but from the economic reason, that what I have learned is that if you run both on-premise and cloud, basically you are kind of like contradict each other. From business development point of view, you are not really kind of like what they call benefit or make money from the on-premise if you are going to go cloud.
Oh.
They're actually contradict each other.
So wait, is that, when you say you, are you talking about Microsoft as a vendor, or are you talking, is the you referring to the customer?
I'm talking about Microsoft that offer both solutions, which are really not supposed
Honestly,
to be parallel.
no. So I'm happy to say that we are not at all conflicted here.
Do you have like financial data to support both model?
Let me, look, I'm a cost center. I'm a cost center. You're asking me about revenue. I spend money. Okay? So, but that said, let me explain to you intuitively why this is a non-issue. On-prem, we make plenty of money with SQL Server, literally in the billions of dollars a year. And on cloud, we are seeing increasing growth. Okay? We have, it's not a matter of what we believe, we don't have a freaking choice. If we are not a player in the cloud, we are toast. Right? Let's take that off the table. So we are going all in on the cloud. That said, as far as on-prem is concerned, take Office 365. It's been super good for us. Yes, there are financial numbers. Just go read the latest SEC filings. Okay? Go look at the numbers there. While the Office on-prem license may be flattening, the cloud is growing much faster. The same trend we expect to happen elsewhere. And in the process, if our presence on-prem acts as a reason for customers to come to our cloud, hallelujah. That's wonderful. Right? For us, it's not an either or, because the option of not investing in the cloud because of potential cannibalization of on-prem, it's a mistake certain others of our competitors have made. I won't say who they are. The names may be Delphic. It's not a mistake we have made. Yeah.
Hi, Raghu.
Yeah.
So the question I have is that you know how all the Hadoop frameworks are evolving. You know,
Yes.
as you mentioned that Yarn, you know, AM is actually being more efficient, right? And Hive is improving, and there are other frameworks that are evolving to be more efficient. but there's an underlying question that no matter how sophisticated technologies and how they're going to evolve, Hadoop still uses commodity hardware, right?
Yes.
So what is the Microsoft vision in the future? How hyper-converged set of future framework?
Yeah, this is a great question, and to be honest, I'm not sure there is a Microsoft opinion. There's views all over the place, right? And I think, in fact, you're going to see the answer that finally emerges be very nuanced. If you take, for example, blob storage, I guarantee it'll be on commoditized boxes. They may not be disks, they may be tapes, they may be other kinds of drives, who knows, but it'll be commodity. If you take the storage in the compute tier, heck, I have no certainty anymore. Is it all going to be flash? Is it all going to be SSD? Who the hell knows, right? If you take compute nodes though, oh yeah, with things like interactivity, you're going to see all kinds of special purpose queues, okay? Modern database systems, SQL Server, DB2, you name it. You give them a big honking box and they can outperform a very large Hadoop cluster, thank you very much, right? So net of it, we are still trying to figure out the sweet spots of how many boxes of what size are the ideal combination for what workloads. But I think scale-out architectures are here to stay, because if you get it right, you can change over time as the hardware evolves the right answer for N and how big the box is without changing your software, right? As long as you architect for this. In terms of storage, should all the data be upstairs, downstairs, or in remote storage? Again, the answers will vary over time depending upon price points. I think the lesson I'm taking away from all those fluxes, architect so that things like the location of data, things like the nature of boxes and how many, the degree of scale out you need to bring to bear, these are not things that you need to re-engineer your software for. These are knobs you can control, because the precise setting on the knobs of particular hardware choices will be transient over the next several foreseeable years. And they may even be different for different layers of boxes.
Thank you. That was great.
Hi. Question on platform as a service. Where do you see the PaaS market going in terms of cloud, whether it's private cloud or public cloud, for example, Cloud Foundry and other technologies like that?
I think private clouds will likely continue to be a vigorous growth area. Public clouds, there's going to be a handful of them. And if you take things like Cloud Foundry, I don't know the answer. I think, take Azure. Our answer is we don't know the answer. So we happily partner with everyone and let 1,000 flowers bloom. Why? Not because we are nice. As far as I'm concerned, you run Cloud Foundry on Azure, heck, I'm happy. I'm making money, right? So whether that will take off is a question of how much custom development on those platforms becomes important to customers relative to the ease of running on whatever particular choice of platform the major cloud vendors have doubled down on, right? That I don't yet have the data to have an opinion. I don't know, okay. Right? But I do want to take a moment to speak about Thomas Watson. 50 years ago, someone asked him, how many computers do you think you will sell? And he said 4. No, wait a minute, maybe 6. And everyone said, what an idiot. Initially they said that because 6 computers? Then they laughed at him, only 6? Right? But when you think about it, he was thinking about a computer as a public compute service to which people would come, do their compute, get results, go back, or do it remotely, the Multics kind of model. It just took a few decades for reality to catch up with this truly visionary man. Our public clouds are nothing but Thomas Watson's computers. And If you ask me how many, there are going to be 5 or 6.
This is probably not a open-ended question, but I live in heart of Silicon Valley, but I've been consulting healthcare and financial services for the past 20 years. So the question is, so the technology, majority of these technologies are enabling some of the business services and the use cases. For example, like anti-money laundering or financial crimes, any of these. So yet, majority of the customers spending a lot of time in the data preparation as opposed to spending in their application. So it's more like a chicken and egg problem for the industry, and the majority of the customers, that's what they're seeing. So what's your thought process or point of view on that one? How?
On what precisely? I'm not sure I got the question.
So the question is more like, okay, how do you see the industry is moving towards that, enabling the customers so that they can spend more time on their business problem rather than the technology?
I hear you. Let me give you at least an answer to what I think your question is. Right? Let me rephrase your question first. For a variety of reasons, people are spending a lot of time prepping their data, pulling the pieces together, rather than doing the business level analytics they care about. So we talk so much about machine learning, but if you take the amount of time it takes to win a Kaggle contest, the vast majority is feature prep, not the actual training or scoring of the models. This kind of way you're going. The other part of the problem is we have so many different tools and so many different variations of every tool. None of them are properly integrated end to end. It's very hard to know what to do. I think at the end of the day, what we're going to see is many more vertical apps, app suites. Take the ERP suites, things like this, that really drove adoption of relational databases in the 80s. With the newer kinds of data lakes we're talking about, you can build similar vertical suites for a much, much broader range of domains and apps. And in doing that, you solve both these problems, right? I think that'll happen. That'll be a big driver. The other part of it will be, I think, the maturation of these systems, Darwinian evolution. A lot of these currently hot things will just not be hot. So eventually, through a combination of these, the space of choices a customer needs to make will be. Please, that's my best guess.
Let's take one more question.
Two more.
Great presentation. Thank you for being here. And it's very good to know that Microsoft is doing quite a bit in data analytics. My question is, for Azure, what is your projection for next 10 years? What is the number of SQL installations you think Azure will replace in next 10 years?
I'm just going to give you a quote from Napoleon. I think it's Napoleon. Prediction is hard, especially about the future.
A guess based upon the data you have been seeing, which may not be public.
A lot?
That says a lot. Thank you.
Yeah, hi Raghu. Thanks for the presentation. Very good. My question is, how Azure is simplifying the machine learning? I mean, are you guys going to, without people knowing the complexity of the models, unsupervised or supervised learning, how Azure is going to help the people? They can load any source of data, and then Azure is going to generate the models and it will help them to choose.
Great question. So there are a few different things we're doing. First off, if you look at AML, Azure Machine Learning. One of the things you have is a drag and drop Canine-like interface for taking a collection of libraries that we have, including scale-out libraries, including versions, pretty much all of R, scale-out and non-scale-out versions, and you can define what your training flow is. We are also integrating this deeply with things like U-SQL and Hive. The previous question, about the one previous to that, about all the time being spent in ancillary work, data prep and the like, we want to simplify that, right? As part to essentially to make it easy for you to create workflows where you have the full experiment all the way from soup to the final model. The second thing we are doing is once you have a model, operationalizing it turns out to be a common challenge. This actually they made really easy. You take a model, including one you train on-prem. You can bring your own model if you will, or take a model trained by this and say deploy, and there's a scoring service. And once your model is installed, deployed, you can have it, you can have the training periodically updated and so on and so forth. You can then have an API to call for with your cases, and the cases are scored, right? So it's a decision service. So there are things like this we are doing. Does it go all the way to what you said? No. Does it make the bar a little lower? Yes. And this is something we think is really important. There's a lot of hype around machine learning, but the reality is the number of people who know how to really do it is a scarce commodity. So anything we do to make this more accessible, we think will count for a lot more than a faster or even a slightly more accurate model.
Thank you.
Please join me in thanking Raghu.
Thank you.